Greetings, detectives. Mrs. McKay here, and we are going to work on learning target clue 6-2, and that's going to be all about translations, and it should be a fairly quick video. We'll see how quick I can make it. Let's start by filling in our learning target. I can use the slope of a line to translate an image. So go ahead and write that in. I can use the slope of a line to translate an image. And before we get started, let's just do a quick review. Let's remember that a translation means a slide. It's one of our rigid motion transformations, and you were introduced to it in our last learning target. And now we're going to just spend a little bit of time exploring translation. So remember that it's a slide. You basically take an image and you make a direct copy of it, and you simply slide it. You slide it from one position to another position, but it's an exact copy. You don't rotate it or flip it. It's just slid, like you took a piece of piece of paper and you slid it along the table. All right. And then a notation of that translation, the thing that we'll probably use the most is going to look like this. XY translates to X plus something, Y plus something. Sometimes you'll see up 4 to the right 3, or to the left 2 and down 1. But if you write it this way, you're saying here's your point, and every point on your image is going to, the x coordinate of every point is going to move to the right if it's a plus or a positive number, and up or down if it's a positive or negative y. So that's one way. Another thing that you might see occasionally is a T, which means translation, and then down underneath it, it might say like to -4. And that means that for the translation, we're going up, or we're going to the right 2, and we're going down -4. The x is going in the positive direction 2, the y is going in the negative direction 4. So those are some different ways that you might see things notated when you're working with translations. All right. Now, the other thing that we're going to be focusing on today is we're going to be looking at translations and how they relate to parallel lines. And so I want to remind us of what we already know about a parallel line and its slope, or two parallel lines and their slope. And what is it that we know? Well, we know that parallel lines have equal slopes, okay? Their slopes are exactly the same. So if I have the line y equals 2x plus 5, well, that is parallel to, we'll just write it like that, parallel to y equals 2x minus 7, okay? Because the only thing that's different about them is their their y-intercept. The first equation starts at 5 on the y-axis, but it goes up 2 over 1, up 2 over 1, up 2 over 1. And the second one starts at -7, but it has the same slope. It goes up 2 over 1, up 2 over 1, up 2 over 1. And if we graphed these, they would look something like this. Okay? So this one would be at 5, and this would be at -7, and you can see that they're parallel. They go up and over the same amount. So parallel lines have the same slope, and we talked about that earlier on, but I just wanted to remind you of that. Now, let's talk about how that relates to a translation. There's one other thing about translations that I want to be able to point out to you, is that when we are moving the individual points or the vertices of, say, a figure like this rectangle here, ABCD. So, this is called a rectangle ABCD. We're going to move each point the same direction. So let's look at point A, and we're going to move it, if we follow this line, all the way up to here, and we're going to call that A prime. Remember, this is our pre-image, and this is our image. And what we do is when we translate our points, we don't change the name of the point. We don't say A translates to E. Instead, we call it the same letter, but we put a little tick at the top, a little mark at the top, and that's called a prime. And so then B becomes B prime, and D becomes D prime, and C becomes C prime. If we were going to translate this one more time, translate this exact same shape, and we were going to translate it, down here, then let's say that A became this point right here, then that would be A double prime, okay? And then 1, 2, 3, 4. B double prime, you get the idea, right? And C double prime, and D double prime. And then we would just connect our points, right? And we've just translated this image a second time. So you just put those little marks, those little tick marks, or little tally marks. They look almost like a little apostrophe next to it. And I don't know if you can tell that that's 2, so make it like that. All right, so that's an important thing for us to know about notation, especially when you're working on any practices or doing anything, or it's asking you. You need to know that A translates to A prime, B translates to B prime. So that's just a quick little thing about that. Now, what I want us to look at is I want us to look at these line segments that are connecting A to A prime, B to B prime, C to C prime, and D to D prime. And tell me, what is the slope of this line segment? What is the slope of this line segment? Tell me what the slope of the line segment is. Well, what you might do is you might say, well, let's see, I could just count up, right? Just count up 1, 2, so it's up 2, rise, over run, and over 1, 2, 3, 4, 5, 6, 7. Up 2 and over 1, 2, 3, 4, 5, 6, 7. So it is 2/7 is the slope of A to A prime. What is the slope of B to B prime? Well, you might have known right away, or you might have needed to count it. So if you counted it, you would have went up 2 and over 1, 2, 3, 4, 5, 6, 7. So it's 2/7. You getting a picture here? What do you notice about these lines? These line segments, A to A prime, B to B prime, they look parallel, don't they? It's because they are parallel. Let's look at D and C. Are they parallel? They sure are. Are they parallel to B and A? Yes, they are. And so what must be the slope of D to D prime and C to C prime? Well, it's 2/7. Okay? So one of the things that is important about, and the kind of a cool thing about translations, is that if you know the slope of the line segment, or the line that the point is on, you can translate the different the different points easily, because often what you're doing is when you're saying I'm going over a number and up a number, or over and back and up, or down and up, or whatever we're saying our translation is, whether we go this way and then down, or this way and up, we know we can figure out the slope of the line that is connecting those points. So that's just kind of a cool thing. And then you can use the slope of the line to also translate that image. So let's go ahead and just quickly think about what the slope of the line segment would be from A prime to A double prime. What would the slope of the line segment be from A prime to A double prime? Well, you would just count it, right? You'd go 1, 2, 3, 4, so -4. And then we would go positive 1, 2, 3, 4, 5, 6, -4, 6. Now, that's what our translation is, but the actual slope of the line would be -2/3 because we would want to reduce it. But the actual translation was a -4/6, right? Or if we were going to write it in translation notation, we would say x plus 6, y minus 4. Do you see how I did that? Or we would say t 6 -4. Okay? So that's just kind of a cool little thing about about translations, is that those line segments are parallel, and therefore it's actually the slope, the slope that you are traveling on that line segment, it ends up being your translation, although you might do double it or whatever. So there's one other thing that you need to know about that, and that is that each of these line segments is the exact same length. They're the exact same length. So let me show you something. What we could do then, and I can prove that they're the exact same length by using the Pythagorean theorem. Suppose that I actually created a triangle, a right triangle right here, using line segment A prime as the hypotenuse, and then A to this point here, which we'll just call that P for point, okay? A to P, and then A prime to P. So do you see that I'm making a little right triangle? Well, what do we know about right triangles? We know that
Power off.
That the Pythagorean theorem says,
power off.
Sorry about that. That A squared plus B squared equals C squared. So if this is, and that means our hypotenuse, right? Our hypotenuse is C, and we'll say that this is A, and we'll say that this is B. So what's A? A is 1, 2, right? So 2 squared plus B squared, which is 1, 2, 3, 4, 5, 6, 7, which is 49, or 7 squared, is going to equal C squared. So 2 squared is 4, plus 7 squared is 49, is equal to 53, and that's equal to C squared. Okay? So that means that C, the length of C, is equal to the square root of 53, which happens to be a prime number, so I'm not going to try to figure out what it is, all right? We're just going to say it's the square root of 53. Now, if this line segment, A to A prime, is the length of the square root of 53, I can then say, if I check out what I can also then figure out what the length of B to B prime is, and I can use the exact same idea of creating a right triangle. Do you see my right triangle right here now? So here's P, another P prime, or we'll call that just another P. And I've got from B to P is going to be our B. And from B prime to P is going to be our A. And look, we've got A is 4 squared, or 4, so 4 squared, plus B is 7 squared is going to equal C squared. And I'm going to have the same thing. I'm going to have this be the square root of 53. So that's one of the reasons why we know that these line segments are the same length. They're not only parallel, but they're the same length. So that's just kind of a cool thing that we can use math to figure out and sort of prove these things. So let's go ahead and use what we know about translations and slopes of lines and see if we can figure out how to make this translate this triangle ABC. We want to translate it a distance of 5 along the same path as the line 3x plus 4y equals 8. So if it's going to follow the same path, if it's parallel to we're basically saying that it's parallel to this line 3x plus 4y equals 8, we need to figure out what the slope of this line is. So let's see, the slope of the line, we need to isolate our y. So we're going to say this is 4y equals negative 3x plus 8. We're going to divide by 4. And we've got y equals negative 3/4 x plus 8. And our slope is negative 3/4. We don't need to worry about what the y-intercept is because all we want to know is that we're going to create lines, segments, from A to A prime and B to B prime and C to C prime, and they're going to be parallel and they're going to have the same slope of negative 3/4. Now I'm just going to go ahead and move line segment, and I can see that this isn't quite right. This triangle is a little bit bigger, so I'm gonna assume that my triangle point starts there because I don't want to have to be doing these half things here. So we're just going to assume that this is where my point starts. So I'm going to translate point A, and I'm going to translate it negative 3/4, the slope of negative 3/4. So 1, 2, 3, and 1, 2, 3, 4. So this becomes A prime. Now I don't really know for sure. I don't really know if I need to just translate it once, a negative 3/4, or if I need to do more than that. The other thing that I know is that the distance of the line segment A to A prime needs to be 5. So let's make this a right triangle right here and figure out what the distance of this hypotenuse is. So we know what A is, so we'll say that this is A, and A is 1, 2, 3, 4. Okay, and we know what B is. B is 1, 2, 3. So according to the Pythagorean Theorem, A squared plus B squared is equal to C squared. So that means A squared, which is 16, plus B squared, which is 9, is equal to 25, and that's equal to C squared. And so if I take the square root of both of these, I get C equals 5. Oh, perfect. So that's what I need. I need this length to be 5, and it is. So that means I only have to translate each of my points, A, B, and C, just down 3 and over 4. All right, so I'm going to go ahead and say that this is A prime. And I think I'm going to change my color so that you can see what I'm doing here. This is A. And then I'm going to translate B down 3, 1, 2, 3, and over 1, 2, 3, 4. And then I'm going to do the same thing for B, which is right here. And I'm going to go down 1, 2, 3, and over 1, 2, 3, 4. And I'm just going to double check the lengths. I don't think I did that right. Let's see, I went down 3, 1, 2, 3, 1, 2, 3, 4. Oh, yeah, did I do that right? What's my distance here? Oh, I know what I'm just not thinking right. Okay, so get myself confused with all these points. So that means you're probably getting confused too. So now I'm going to connect these two. And I'm going to look at my, not at my triangle that I made that was the translation, okay, not the red, but I'm going to look at my actual golden colored, my golden one, and it is, the length is 1, 2, 3, 1, 2, 3, and I just created a 1, 2, 3, 1, 2, 3. So I just translated this. So that's kind of a complicated way to do it, but I just wanted you to see kind of the cool thing about translations, and that you can use slope. If you know the slope of the line segment and you know the distance, you can figure out how to translate something. All right, let's do this one down here. It says this one doesn't have a drawing. It looks like it does, but it doesn't. It says the vertices of a triangle are at the points 2, 1, 3, 4, and 4, 2. After a transformation, the point 2, 1 has been translated to -1, 3. What are the coordinates of the other two vertices? So we're going to have to figure out, what the rule was. What did we do? All right, so we can actually graph it and we can figure it out. So let's go ahead and see. Let's see, we've got, I'll make this be my coordinate plane here. And we've got 2, 1, and 3, 4. Is that right? 1, 2, 1, and 1, 2, 3, 1, 2, 3, 4, and then 4, 2. So I think that's my, did I do that? 1, 2, 3, 4, 1, 2. Yes, so that's my triangle, all right? And I can actually connect the lines if I want. And what it says is that after a translation, 2, 1, which we'll go ahead and call this point A, okay? 2, 1 has been translated to -1, 3. So I'm going to make that a different color. So -1, 3. 1, 2, 3. All right, so this becomes A prime. So the question is, what are the coordinates of the other two? We want to know what are the coordinates of this one and this one when we translate them. Well, what did we do? What we can do is we can actually look at our translation, and we can either use slope of these, we can connect these two right here. If we connect these two, let's use even a totally different color, like maybe this bright green. How did we get from A to B, or to A prime? How did we get from A to A prime? Well, our slope of this line segment would be up 2, right? So we would say 2 and back, or negative 1, 2, 3. So negative 2/3. That's the slope of our line segment. So then that means that we can take each of these other points and go up 2 and back 3 to figure out what the translated points are. Or I could just slide them. But I don't want to always have to draw. I want to be able to think about this. I want to be able to think about, how did I figure out the slope between these 2 points? Well, if I figured out the slope between 2, 1, or 2, 1 here, and negative 1, 3, to figure out the slope of the line, remember it's the change in y over the change in x. So if we have from 1 minus 3 over 2 minus a negative 1. Do you see what I just did? I took y1 minus y2, and then over x1 minus x2. So 1 minus 3 is 2, and 2 minus a negative 1 is 2 plus 1, which is 3, and this is a negative, sorry, that's a 1 minus 3 is a negative 2. So it's the same thing, negative 2/3. So once I know that, then I can do the same thing for these other points, okay? So if I'm going to take my slope of 3, 4, or my point 3, 4, and I'm going to translate it along the line segment, negative 2/3, I'm going to take 3, and I'm going to subtract 2. Or did I go, I don't think I'll do a negative 2. I think I'll do, I think I'm going to follow my same rule here, which is I went up 2, because that does matter, right? I went up, it matters which I do, x or y. I went up 2 and back 3. So I'm going to take my y, and I'm going to add 2, and I'm going to take my x, and I'm going to subtract 3. All right? So if I take my y and I add 2, that becomes a 6. And if I take my 3 and I subtract 3, that becomes a 0. So that means that this point, 3, 4, translated to 0, 6. Okay, so let's see if that actually worked. Let's see, I would have gone up 2, 1, 2, and back 3. 1, 2, 3 is right there. And let's see, this is 1, 2, 3, 4, 5, 6. Yep, 0, 6. See if you can do this one, 4, 2. Using that same rule, we're going to go up 2 and back 3. So you should have taken your y value. You should have gone up 2. So 2 plus 2 is 4. And your x value, you should have subtracted 3. And that would have been 1. So 4, 2 should have translated to 1, 4. Now let's see if that works. If we take this one, we would have gone up 2 and back 1, 2, 3, right there. And when we connect our lines, and there we've just translated our vertices. Okay, we've translated our triangle. All right, so now let's practice this a little bit. I've got a little bit of practicing to go on to happen here. So it says, I want you to look down here. We're going to use this down here. We're going to use these figures right here. Do you see this coordinate plane right here with line segment BC and line segment B prime, C prime, and then we've got this square MATH map. We're going to use that to answer these questions up here. What is the translation rule for BC to B prime C prime. Take a look at it and then tell me, what is the translation rule? Well, to figure it out, you needed to first look and see, what did you do to get from B to B prime? What did you do? Well, you went, and now we're going to actually look here at this. What did we do to x? We added x. Let's see. We added to x 1, 2, 3, 4, 5. So from B to B prime, we went to the right. We added 5 to the x value, and we added 1, 2, 3. We added 3 to the y value. So we're going to say x plus 5 x plus 5, y plus 3. That's our translation rule. All right? Now, what is the slope of the line segment connecting B to B prime? Well, what's the slope? We went up 3 and over 5. So now, answer this question. What is the slope of the line segment connecting C to C prime? That's easy. You should know that it's the exact same slope, 3/5, right? The tricky part about when we talk about slope, the tricky part is that we have to make sure that we are always doing rise over run, right? And so when we're writing our translation rule, we write it as a coordinate point, x plus however much we're going over, y plus however much we're going up. But when we talk about the slope of the line segment, we write it as rise over run, okay? Now, let's do this last one. A square is translated on a coordinate plane. Here's our square right here. The slope of the line segment connecting point M to point M prime is -2/3. If point T is at 5/3, what are the coordinates of T prime? Okay, little tricky. I'm telling you what the slope of the line segment is to connect point M to point M prime. And I'm telling you that point T is currently at 5,3. So what are the coordinates of the point T prime? See if you can figure that out. All right, so how did you do it? Did you think about this line segment being -2/3, meaning that you're going to go down 2 and to the right 3? You should have, okay? So if that's the case, then all you have to do is take point T, which is 5/3, and we're going to go down 2 from 3, and we're going to go to the right 3 from 5. So 5 plus 3 would be 8, and 3 minus 2, because that's a -2, minus 2 is 1. So our new point for T would be 8, 1. So it translated down 2, but over here. So let's see. If this was 5, 1, 2, 3, and then down 2 would be here. So that's where T is, right there. That's T prime, right there. And actually, if we wanted, we could then create the rest of the square. And we wouldn't, and you can always do it different ways. You can translate each point, or once you know what your shape is, and this happens to be an easy shape, I know it's a 2 by 2, I can just go up 2, over 2, so this is A prime, and this is M prime, and then this one is H prime, and then I just have to connect my points like that. And that's translation, with a few little tricky things that it's just good for us to know these things about translations. Translations are probably the easiest thing to do, but isn't that cool that something that we learned way back when we were studying linear equations can apply to something in geometry? All right, go ahead and write a key idea down here that will help you to remember, and I'll see you in class.